Okay, we're in the part 2 of piecewise functions. We broke it up into 2 pieces yesterday. We were given a graph and told to create the function like this. Now we're given the function where we're told to graph it. So these next few sheets are in your notes. That's going to be your homework. 1, 2, 3. The back is not your homework. So I'm going to do the first one with you to show you what it's going to look like on your homework, and then we're going to actually do notes a few pages ahead. I've never found a sheet that I really liked, so let's just work on the homework first. So I'm going to graph by starting with -2. Okay, so I'm going to make a table of values. So I'm going to make an x and y table. I'm going to start with -2. I'm going to substitute -2 into here. If you need to write it out, that's fine. If you need to write -2 plus 5, and then say, okay, I get 3, then that's fine. But I don't want you to confuse yourself. I want you to write -2 and then 3. So I'm going to go to -2, and then I'm going to go to 3. But you have to realize you don't actually get to use -2. There's not an output. It's just so close to -2. You could use -1.99999. So that's why we have an open circle, because we get so close to it, but we don't actually touch it. All right, and then what's a number less than -2? -3. When I substitute -3 into the equation, I'm going to get a +2. So I go to -3, and I go up to +2. We'll keep going to see a line and feel a pattern. We can skip a little bit. We don't have to use -4 next. Let's go to -6. 1, 2, 3, 4, 5, 6. When I put -6 in, I'm going to get -1. So I realize that I'm going to keep going. So I'm just going to put an arrow here. Okay. The next one is also an inequality. It's open. We actually get to use -2 though. So when you substitute -2 in there, you're going to get 4. 4 minus 1 is 3. So -2, 3, 1, 2, 3. Then I'm going to use -1. When I substitute -1 in there, I'm going to get 2 minus 1 is 1. So -1, 1. Then we're going to put, I don't know, let's put a bigger number. Let's put like 3 in there because it's greater. If I put 3 in there, I'm going to get, okay, so something's off. If I put -2 in there, I get 4. 4 minus 1 is 3. So -2, oh, let's just go up 3. 1, 2, 3. Oh, it overlaps. And then we get this one. Let's try 3. 1, 2, 3. Put in 3, we get -7. Okay, so that's fine. So see how I made a mistake there? Just cross it out. We're going to keep going. If you just want to stop there and put an arrow like you're going to keep going, that's fine. Okay, so that's what your homework's going to look like. Now it says, is this a function, yes or no? Yeah, it's going to pass the vertical line test. These are on top of each other, but they're both not equal to. So yes, it's a function. Substitute in 3. Well, 3 is greater than -2. So -2 times 3 minus 1 is -7. Put in -4. Well, -4 is less than -2, so -4 plus 5 is 1. Well, let's try it. 1, 2, 3, 4. Yeah, we get 1. -2. Your answer is going to be 3. Let's try it. 1, 2, 1, 2, 3. Yep. So that's what you're going to do for each one. So let's practice these again. Flip a few pages until you get to this worksheet, piecewise functions. I really like these 2 examples to use to help you better understand. So what happens if you get when that's an open-ended? When I say open-ended, like it's continuing, I should say. And when you're in between 2 points. So let's start with this one because it's the first one. The beauty of these is that they're linear equations. You don't have to use -3, -2, -1, 0, all the way up to 1. All you need for a line is just 2 points. So these ones are actually easier. So we're going to make a t-table, a t, and then we're going to substitute in 3. negative 3, and we're going to also substitute in 1. Those are going to be the endpoints of the line. So when I replace negative 3 into here, I'm going to get negative 3 plus 2, which is negative 1. When I replace a positive 1 in for x, I'm going to get 1 minus 3, which is negative 2. So I'm going to go over to negative 3, a positive 1, and I'm actually an open circle because I'm not equal to. Here, I'm going to substitute positive 1 in, and I'm going to get negative 2, closed circle. And we connect the lines. The end. Okay? All right. Here, okay, we are going to do the same thing. Oh, we didn't finish this one. I apologize. So we're going to make a t-table again. And we start with 1. It says numbers bigger than 1. We could do 1, 3, 5. Okay, just enough to get it flowing. So I'm going to substitute in 1. 1 minus 3 is negative 2. So we go to 1, negative 2. Oh, it's an open circle on top of a closed circle. That's fine. Then we're going to go to 3. 3 minus 3 is 0. 5. 5 minus 3 is 2. So go to 5, up 2. So it's just going to keep going. All right. We're going to do the same thing again. We're going to have 3 t-tables. So we're going to have one that starts with negative 4 and ends with negative 1. We're going to have one that starts with negative 1 and ends with 2. And then we're going to have one that starts with 2. And you can do 2 and then just skip to another number. You don't have to do more than one number. It just helps me remember that I'm going to keep going rather than have a segment. So here, if we start with negative 4, oh, it has to be 4. And if I put in negative 1, it has to be 4. So I'm going to go to negative 4, and we get 4. But it's an open circle because we're not equal to. This one we are, so it's going to be a closed circle. It's a linear equation, so connect the lines. All right, same thing here. I'm going to substitute negative 1 to get negative 5. I'm going to substitute in positive 2 to get 1. So negative 1, 1, 2, 3, 4, 5. Negative 1, negative 5. It's going to be an open circle. 2, 1. Open circle. And lastly, 2. When I put in 2, I get negative 2. Let's jump a little. Let's try 5. 5, if I put in 5, I get negative 2. So go 1, 2, 3, 4, 5, negative 2. Open circle. And 2, 1, 2. Negative 2, open circle. Oh, see, this is why I forget it. Because it's actually going to keep going. So maybe, if you're like me and would forget, do another point. Try 2, try 5, try 3. Because if you don't, you might make a segment like I just did and forget. And that's why I always did it. Okay, so these are your piecewise functions. This is your homework, those 3 pages. And then that's it for required homework. Now, this video you can pause and go back to later, but these are other functions too. They are called rounding up or rounding down functions or greatest integer functions. So on this paper here, the only requirement I'm going to have you do is to physically round up or round down. I'm not going to have you graph them. Okay? So here, you're actually rounding down with these brackets. This one, you're rounding up, and these are just absolute values. So for instance, how would I round down negative 9, 2.3, or 0.23? Well, negative 9.23 is between negative 9 and negative 10. Negative 10 is actually lower, so your answer is negative 10. Absolute value of 13.13 is 13.13. Rounding up 7.8 is 8. Rounding up negative 1.88. People start to go with negative 2. It's actually negative 1. So then your answer is 7. Okay, I want you to pause the video. I want you to continue to do this. And then we'll check back. The end. Okay, so I'm just going to have you round up and down these functions. I'm not going to have you actually graph them. And I'll show a little video on Monday about how these functions, what they would look like. They're called technically step functions, the greatest integer function, or rounding up or rounding down, depending on what your textbook is, what format you're using, and so forth. But you're not tested on graphing, just can you round up or can you round down?